Right, today we're going to look at the relationships between proportional parts of triangles with parallel lines inside the triangle. So the theorem here is if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the side into proportional segments. So essentially it's going to be a shortcut for finding missing side lengths. So we have this example, and we know that these lines are parallel from those red markings. Since they are parallel, what that means is we're going to have a proportion, a nice proportion, which we can just set up using the following. So we could say 3 over x is equal to 8 over 12. And then use what we know about cross multiplication and then just to solve that. So when we cross multiply, we get 8x equaling 36, and dividing both sides by 8, we get x is equal to 4.5. Remember to go back and also look at what they're asking for. They were looking for the distance here, SU, so SU itself is equal to 4.5 since that was x. Okay, in the next example, similar here. What we're going to do is set up a proportion, and we're going to just say that since they're parallel, we can again set up a proportion. X is to 6 as 10.5 is to 4. Again, cross multiply and divide. And we get xy is equal to 15.75. Again, make sure you go back and check. It's asking for by. So by, again, is just x value, so it's just 15.75. Okay, so this is a converse, and remember, converses take an if-then statement and then switch it around. So in this theorem, what we're going to use here is if we know that these are proportional, we can then say that these lines definitely are parallel. DH18, and we know that, I'm just going to show you an example. This would be, if this is x, then this is 2x, so then we can set up a proportion like that. And what you can do then is to just cross multiply, and you're going to just see that if we do get equal values on both sides, then it is indeed, they are parallel. So this is true. Okay, in the next one, it tells us that this segment here is WA is 18. It says AZ, so that's over here is 32. And we have that YZ is equal to 25. And we have that this is 15. So if I set up those proportions here, we want to see, is this really truly proportional? And when we do that, we look at our cross products. So go ahead and see if you can multiply what those things are. I believe I got 480 versus 450, so no, so the lines are not parallel. Okay, the next vocabulary word is a segment, mid-segment. So a mid-segment is if you were to take a line and then cut it in half here, it would cut that line into halves. Okay, so each side of a triangle has a mid-segment. So if we look at this one, this here is the mid-segment, which means this is congruent to that. And finally, we would have this side over here. If this point P is the midpoint of that side, then these would be congruent. So if we know the mid-segment theorem, if the mid-segment is parallel to one side of the triangle, then the length is half. So in this theorem, we're going to use this. If we know this value, let's say 16, then this has to be half of that, or 8. so in this example, we're going to be looking at this mid-segment idea again. So they want us to find AB. They give us that this is the midpoint, so this is congruent to that. This is the midpoint, so that's congruent to that. This is the midpoint, so this is congruent to that. And we also know that we're going to use the fact that these are indeed parallel to figure out that segments are going to be like double each other. So we'll start first of all with this length here. If that's 5, then this has to be 10. So that's AB. And then we have if this side right here is 18, and then this will be half of that, so half of 18 is 9. And then since those lines were parallel, we can use the same theorems of alternate interior angles to figure out other things. So if we have that this angle right here is 87 degrees, then they're asking AFE, which is here. Well, AFE is an alternate interior angle, so that is also going to be 87 degrees. So in the next one, I'd like you to press pause and try that one out, and then we'll go over it. Okay, so this next one here, we kind of saw this earlier in the previous chapter, but we do know that if these parallel lines are cut by this transversal here, then these parts on the side are not necessarily going to be congruent, but they will be proportional. So you can set up proportions using this idea as well. So if we look at this example, these lines, let's assume that they are parallel, then we could say that this segment is proportional to this segment, and this segment is proportional to this segment. So we could say 13 over 26 is equal to 16 over x, and when we go ahead and just cross multiply and divide, we get x is equal to 36, and that's what we were looking for in this problem. So I want you to press pause, go ahead and try this one, and figure out the value of x. Okay, so in this example, we get cross multiply and divide, and we get x is equal to 5. So this is the last corollary we're going to be looking at today. If 3 or more parallel lines are cut off congruent segments, then they cut off congruent segments in every transversal. So this is saying, when we did see this one before, that these two here then would be proportional. Actually congruent, not proportional. So in this case, what we can do is to assume if these two are proportional, congruent, then we can set up an equation to say something like this, and we can then use our algebra skills, and we get 2x is equal to 12, divide both sides by 6, and we get x is equal to 6. So if we know this side over here is 6, then this is 11. So we could then set up a proportion with that. This would be 11, this would be 11. So then lastly, these guys are going to be congruent to each other, so we can set up another equation and solve that. So if we subtract 6y, we get 3y is equal to 6, divide both sides by 2, and we get y is equal to, not 6, y is equal to 2. Okay, go ahead and press pause, try the next one, and then we'll come back and check your work. Okay, solving for A on this one is a little bit easier than solving for B, so I'm going to give you a strategy for working with the fractions, because I know everybody kind of gets freaked out when you're working with fractions. So if this is congruent to this, then this here is going to be congruent to that. So say 3b is equal to 5/3 b plus 2. Okay, So most times we don't like working with fractions. So a strategy that I suggest is we want to get rid of that fraction of a 3. So what we're going to do is we're going to take this whole thing and we're going to multiply everything by 3. Okay, so what that means is we're going to take 3 times 3b. We're going to take 5/3 times 3, put b back in there, plus 2 times 3. So the strategy will eliminate all of the fractions if you're multiplying by the least common multiple of the denominator. So we get 9b is equal to 5b plus 6. So we would subtract 5b from both sides, and we get 4b is equal to 6. Divide both sides by 4, and we are going to get a decimal answer now. B is equal to 1.5.